Assalamu alaikum.
Anything special?
Class.
No special is your class. Okay, pass it over.
Good afternoon, dear student. Okay, I suppose I'm audible now. Okay, I'm audible, so I'm moving further ahead with the class. So in today's class, we'll be talking about the trends of atomic ionic size, ionization energy, electron affinity, electronegativity only. Polarizability I'll be talking about in the next class. Okay, so let's talk about the periodic trends. So what are periodic trends? Actually, these are nothing but these are the specific patterns that are being present in the periodic table that helps in finding out the different aspects of elements, including its size and its electronic properties. Okay, so major periodic trends basically comprises of electronegativity, ionization energy, electron affinity, atomic radius, melting point, polarizability, and metallic character. So we'll be only talking about these many things, that is electronegativity, ionization energy, electron affinity, atomic radius with its atomic, you can say ionic radius as well. Then polarizability. Okay, nothing else. We'll not be talking about melting point and metallic character. So this is only for your information. So the periodic trend basically arises from the arrangement of the periodic table that provides the chemist or the student or the faculty with an invaluable tool which helps in quickly predicting the properties of the element. Okay, so these trends has been existing because of the similar atomic structure of all the elements within their respective group, or you can say family, or to the periods, because of the periodic nature of the elements. And this has been told to you in the last class also. It has been arranged, or the periodic table has been arranged on the basis of its atomic number. So the atomic number basically increases by 1. Okay, by unit it has been increasing, so you can easily predict the properties of the elements, you can say. So let's talk about electronegativity. So what is electronegativity? It is nothing but it's a chemical property which helps in describing that an atom's ability to attract and bind with electrons. Okay, So because of the electronegativity, because since it's a qualitative property, so there is no standardized method for calculating the electronegativity. However, the common scale which has been used to calculate or to just explain the electronegativity is the Pauling scale, which has been named after the scientist Linus Pauling. Not talking about this Pauling scale, it is quite in detail, but you should know ki who has given the values for electronegativity for individual atom. So the number assigned by the Pauling scale is nothing but they are dimensionless due to the qualitative nature of the electronegativity. So electronegativity values for each element can be found on certain periodic tables. So हर periodic table पे mention नहीं रहता, but there are certain periodic table where they are been mentioning the values of electronegativity as well. So we came to a conclusion that electronegativity is nothing but it's the atom's ability to attract and bind with other electrons. Okay. So again, repeating the same thing, it is the measure of an atom tendency to attract and form bond with electron. So this property basically exists due to the electronic configuration of the atom. So most atom they follow octet rule. ये आपको पहले भी बताया था, last class में भी बताया था. And there are only two, we can say, atom. They have been following nothing but the duplet rule, that is hydrogen and helium. So here in octet rule, it the valence electron or the valence shell basically has 8 electrons into it. Okay, so because the element on the left side of the periodic table have less than a half full valence shell, so the energy required to gain electron is significantly higher as compared with the energy required to lose electron. So as a result, the element on the left hand side of the periodic table generally loses electron while forming bond. So we can say the element on the right side of the periodic table are more energy efficient in gaining electrons to create a complete valence shell of 8 electrons. So the nature of electronegativity is basically being described that the more inclined an atom is to gain electron, the more likely that the atom will pull electron towards itself. So when we talk about the periodic, एक second. When we talk about the periodic table, तो electronegativity जो कैसी रहेगी वो, ये पीरियोडिक टेबल है, दिस इज एस ब्लॉक, दिस इज पी ब्लॉक, सॉरी डी ब्लॉक, दिस इज पी ब्लॉक, एंड बीच में नीचे जो रहता है वो है एफ ब्लॉक एलिमेंट्स. सो आप जैसे जैसे इस तरफ जाएंगे तो इलेक्ट्रोनेगेटिविटी जो रहेगी वो बेसिकली क्या होगी, इंक्रीज हो जाएगी. क्यों होगी? क्योंकि यहाँ पर टेंडेंसी अट्रैक्ट करने की, गेन करने की बढ़ती जाएगी, बिकॉज दे आर कमिंग क्लोजर टू द इनर्ट गैस, राइट. सो शेल वही है, इलेक्ट्रॉन्स उसमें ऐड होते जाएंगे तो आसानी से क्या होगा, यू विल see the increase in electronegativity. So from left to the right across a period, electronegativity basically increases. ये अभी मैंने अभी बताया आपको. So if the valence shell of an atom is less than half full, it requires less energy to lose an electron than to gain one. So the valence shell is more than half full. It is easier to pull the electron into the valence shell than to donate. तो हम ऐसा बोल सकते हैं half filled, fully filled orbitals are stable, right? अगर हाफ फिल से ज़्यादा, फॉर एग्जांपल ये पी है शेल, इसमें कितने इलेक्ट्रॉन्स रहते हैं, 6 रह सकते हैं मैक्सिमम. अगर इसमें 3 रहेंगे तो कोशिश करेगा ये खींच ले अपने तरफ, देने से ज़्यादा बेहतर रहेगा ये खींच ले अपने तरफ. सो इलेक्ट्रॉन नेगेटिविटी जो रहेगी वो बढ़ती जाएगी. ओके फाइन. सो जब आप ऊपर से नीचे आते, व्हेन यू मूव फ्रॉम टॉप टू बॉटम इन अ ग्रुप, सो इलेक्ट्रोनेगेटिविटी डिक्रीजेस बिकॉज नंबर ऑफ एटॉमिक नंबर जो है वो इंक्रीज हो रहा है, or there is a greater distance between the nucleus and the electron or the valence electron. So the atomic radius basically increases. So atomic radius अगर बढ़ता है तो electronegativity automatically क्या हो जाती है, वो decrease होती जाती है from top to bottom. So there is certain exception which has been there, which includes the noble gases, lanthanides and actinides. So the noble gases basically they possess a complete valence shell and they usually do not attract electrons. So the lanthanides and the actinides also possess more complicated chemistry than does not generally follow any trends. Therefore, noble gas, lanthanides and actinides do not have electronegativity values. Okay. So as for the transition metal, although they have electronegativity values, there is a little variance among them across the period up and down a group. This is because their metallic property affect their ability to attract electron, and it has been easily on as easily as other elements. So according to these two general trends, the electronegativity of fluorine is the highest. So this is a general one. Electronegativity from left to right has been increasing, and top to bottom decrease होगा तो no doubt bottom to top जाएंगे तो increase होगा. Let's talk about ionization energy. Ionization energy is nothing but the energy which has been required to remove an electron from a neutral atom in its gaseous phase. Conceptually, ionization energy is opposite of electronegativity. Lower this energy, more readily the atom becomes cation. ठीक है, एक इलेक्ट्रॉन करेगा तो पॉजिटिवली चार्ज हो जाएगा, इसलिए उसको हम बोल रहे हैं cation. Therefore, higher this energy, more likely that the atom becomes more cation, right? So elements on the right hand side of the periodic table have higher ionization energy because their valence shell is nearly filled. So the element on the left side of the periodic table have low ionization energy because their willingness to lose electron and sorry, to lose electron and become cation is less. So क्या हो जाता है, low ionization energy होगी. Therefore you can say ionization energy increases from left to right on the periodic table. So another factor which affects the ionization energy is nothing but the electron shielding effect. So what is electron shielding? ये मैंने आपको कल भी बताया था. It is nothing but the ability of an atom's inner electron to shield its positively charged nucleus from its valence electron. Okay, so it basically weakens up the force of attraction between the nucleus and the valence shell. So while moving to the right of the period, the number of electrons increases and the strength of the shielding also increases, right? So as a result, it is easier for the valence shell electron to ionize. Thus, the ionization energy, you can say, decreases down a group. So electron shielding is nothing but it is also known as a screening effect. Trend देख लेते हैं. The ionization energy of the element within a period generally increases from left to right. This is due to the valence shell stability, fine. And the ionization energy of the element within a group generally decreases from top to bottom. This is due to electron shielding. तो ये दोनों आपको याद रखना. These are two important. So the noble gases possess very high ionization energy because of their full valence shell. जो ग्राफ में इंडिकेट है, जो मैंने यहाँ दिखाया नहीं है. So you should note that the helium has the highest ionization energy of all the elements. Why? Because दो ही रहते हैं उसमें, and सबसे closest है वो न्यूक्लियस के पास, तो उसकी ionization, उसमें से इलेक्ट्रॉन निकालना means you need to give more amount of energy. ठीक है, sorry. So some elements have several ionization energy. ठीक है, so these varying energies are referred to as first ionization energy, second, third, and so on and so forth. So the first ionization energy is the energy which is required to remove the outermost or the highest or the energy electron. Okay, so the second ionization energy is the energy which is required to remove the second high energy electron from the gaseous cation. So पहले cation बनेगा, उसमें से हम फिर से एक और इलेक्ट्रॉन निकालेंगे तो वो सेकेंड आयनाइजेशन एनर्जी कहलाएगी. तो हम देखते हैं ये गैशियस है आपका, कोई भी आपने एटम ले लिया है गैशियस फॉर्म में, इसमें से एक इलेक्ट्रॉन मैंने निकाल लिया. ठीक है, ऊपर प्लस होना चाहिए बिकॉज इसमें आता नहीं है इसलिए मैं दिखा नहीं पाई हूँ. सो यू आर लूजिंग वन इलेक्ट्रॉन. इसी में से ये जो पॉजिटिव बना हुआ है ना गैशियस फॉर्म में, इसमें से हम एक और इलेक्ट्रॉन निकालेंगे तो ये क्या हो जाता है X2+, राइट. सो दिस इज टर्म्ड एज सेकेंड आयनाइजेशन एनर्जी. तो हम ये याद रखेंगे कि जो आयनाइजेशन एनर्जीज हैं दे बेसिकली दे आर बीन इंक्रीजिंग, फाइन. सो लेफ्ट टू राइट हम जब जाते हैं तो इट इज ऑल्सो इंक्रीजिंग. व्हेन यू मूव फ्रॉम टॉप टू बॉटम इट इज डिक्रीजिंग, डिक्रीज करेगा क्योंकि बिकॉज ऑफ द साइज ऑफ द एटम. ओके, okay. Next is, let's talk about electron affinity trends. As the name suggests, electron affinity is the ability of an atom to accept the electron. Fine. So unlike electronegativity, electron affinity is a quantitative measurement of the energy changes that occurs when an electron has been added to a neutral gas atom. So more negative the electron affinity value, the higher an atom has the affinity for electrons. Okay. So electron affinity basically decreases down a group of element because each atom is having a you can say it is larger than the above atom because the atomic radius has been increasing. So this means that an added electron is further away from the atom's nucleus as compared to its position in the smaller atom. So as the larger distance between the negatively charged electrons and the positively charged nucleus is being more, so the force of attraction becomes very much less. So electron affinity automatically decreases. Clear? So moving from left to right across a period, so the atom becomes smaller and smaller due. Okay, so the force of attraction is also stronger. So this causes the electron to move closer to the nucleus, thus increasing the electron affinity from left to right across a period. So vice versa will be there from when you move from top to bottom. So electron affinity increases from left to right within a period. This has been caused due to the decrease in the atomic size, whereas electron affinity decreases from top to bottom within a group because of the increase in atomic radius. So every property basically is been dependent upon the size of the atom. So this is just the pictorial presentation where we see the increase in electron affinity from left to right, and we see the decrease in electron affinity from top to bottom. Let's talk about the atomic radius trend. We'll talk about ionic radii afterwards. So what is atomic radius? Atomic radius is one half of the distance between the nucleus of the two atoms, right? Just like the radius is nothing but the half the diameter of a circle. However, this idea is complicated by the fact that not all atoms are normally bound together in the same way. Some are being bounded by the covalent bonds, some are being bounded by the ionic bonds, and some may be in the form of metallic crystal. So it is possible for a vast majority of the elements to, it is like we know कि majority of the elements they undergo bonding with the help of covalent bond, single covalent bond. So we can easily find say that the covalent radii of this molecule is being termed as basically atomic radii. So the distance which has been measured here is in picometers. Okay. So atomic radius or atomic patterns are observed throughout the periodic table. Okay. So atomic size gradually decreases from left to right across the period. Okay. So this is because within a period of family of elements or electrons have been added to the same shell. Left to right जाते हैं तो same shell ही रहता है, उसी में electrons add up होते जाएंगे. However, protons have been added to the nucleus, making them more positively charged. So nucleus पे charge बढ़ता जाएगा, इसलिए size जो रहेगा वो छोटा होगा when you move from left to right. Okay, so there will be a greater nuclear attraction. So nuclear attracts the electron more strongly, pulling the atom's shell closer to the nucleus. So the valence electrons are being held closer towards the nucleus of the atom. As a result, the atomic radius decreases. So when you move down the group, the atomic radius increases. So the valence electrons occupy a higher level due to the increase in quantum number. So as the quantum number increases, the nucleus, or you can say there will be a lesser force of attraction. So in other words, we can say that atomic radius decreases from left to right within a period, and it is being caused by the increase in the number of the protons and electron across the period. So atomic radius increases when you move from top to bottom. This is because of the electron shielding effect or this electron screening effect. Fine. So here we have finished with majority of the properties periodic trends. In the next class, we will be talking about the polarizability and the penetration of orbitals. Okay. Thank you. So the reference I have given, my book, Vindara Jain and Jain Google. Thank you so very much.